Quick sort of history lesson.
65% power.
We got tons of time. This is a circle. You've seen it before. 360 degrees in a circle. Does anyone remember why we go for 360 for a revolution? Or has anyone thought about it? It's a bit of a weird one because the rest of things we tend to do in hundreds. So you might even think, why don't we do 100 around a revolution and 25 in each chunk? I mean, that would make some sense. The reason that people think we went 360 is because if you imagine the middle is the sun and a point here is the earth, it takes us about 360 days to do one revolution, meaning each day we move about 1 degree. Clearly it's 365.25 or something, but that divides up terribly. But 360 divides pretty nicely. We cut it into 90s, we can cut it into 60s or 30s or 45s. It's a nice number to work with. 360 is pretty good. And we go approximately 1 degree around the sun every day. Cool, there's your fun fact. So, lots of the measuring systems we used originally came from things we could see around us. So, the imperial system for length, you guys know inches, feet, yards, miles, you'll have heard of them. They all came from approximately something you could see in nature. An inch is about that. A foot is about, well, that. A yard is about that. But these abouts don't convert nicely. Like there's 12 inches to a foot, there's 3 feet to a yard, and I have no idea how many yards to a mile. And if you ever ask someone inches to a mile, even someone who uses it, like the Americans, they're gonna look at you confused. Like it doesn't convert nicely. So there was an effort to standardize this. And the French led this effort. And then the French invaded a lot of Europe, which helped spread the effort. And so they came up with things like meters. And rather than using Fahrenheit, they decided, well, the Fahrenheit thing's a bit nonsense. We're going to go between 0 freezing, 100 boiling. So Celsius makes sense. And they said, rather than using the 360, we're going to say, well, everything else we do is in hundreds. So I'm going to say from here to here is 100. Yeah, and this was the French system. And the French system called theirs gradients. And therefore it's 100, 100, 100, and it's 400 in a circle. And Celsius caught on, meters caught on, gradients did not catch on. And now they're a bit of a joke. If you look on your calculator and go into the settings, you'll find 3 options there in terms of degree, or in terms of angle. There's degrees, which we're comfy using, have used from ages. There's radians, which we'll teach today. And then there's gradients, which nobody uses. But a gradient is just that. And your calculator has gradients, but we just never use them. Don't know why. This year we'll bounce between these two, which is confusing because you'll have to change the settings on your calculator. But year 12, you just use this. Mathematicians only use radians. Radians work much more nicely. So I guess the start of today is, what is a radian? This one, used historically, everyone has a pretty good understanding of this one, what it is. This one makes some sense, but we decided not to use it, don't know why. This one is initially the least intuitive, because the origin story of it is, why don't we relate the angle, so how far something's separated by, it's still on it, just turn the screen off.
Oh.
With, I know, this is an upgrade because the school's one kept dying. Why do we relate the angle and think of it less as like an angle, the separation, and more like a distance? So, if we travel 1 this way, and then we start heading round a circle, and we head round that circle for 1, that will always make a measure. And that separation is called 1 radian. And they use a little c to denote radians, and I'm not sure why. But they noticed that it doesn't matter what the radius of the circle is. I could make the radius 7.6 centimeters, as long as I then continue round the circle for 7.6 centimeters, that angle is exactly the same. So, this 1 radian thing works out neatly. Now, if we want an approximation of how that looks in degrees, whoop, come on, don't freeze on me. I'm trying to zoom in. No. This is a decent approximation. If I go 1 radius out and then 1 radius around, are you happy that that 1 radius around will be slightly less than if I went 1 radius out and 1 radius straight up? The straight up pushes it slightly further up. And you guys know that the equilateral triangle, like 1 radius, right, and radius, is 60 degrees. The bendy version of this, where we're going around a circle, will be a separation of slightly less than 60. What I guess I'm saying is that 1 radian is just under 60. So it's only just less than 60 degrees. It's a bit under 60. Now, let's just consider the case of where we have a 1 as a radius. If we have a 1 as a radius, and I want to travel half a circle. If I want to travel half a circle, what will this distance be? And the way, I wasn't going to wait for an answer, I was just going to give it. But if you, does anyone know off their head, top of their head? No, it's, you might recall that the circumference of a full circle is 2 pi r. So the circumference for half a circle will just be pi r. And because we define our radius as 1, this length here is pi. So if 1 across 1 around is a 1 radian, 1 across pi around, in terms of radians, gives you 180 degrees, or half a circle. And this gives us our sort of defining feature of radians. Pi radians is the same as 180 degrees. So if I go pi around a circle with a radius of 1, I've done 180 degrees. What it means is that 2 pi is 360, because the circumference of a circle with a radius 1 is 2 pi. So we will use this as a conversion. So a bit like the French making up a system, saying that we can make this 100 or 90 or any number we want, mathematicians have made a system where they say, oh, we don't want 100 there. From here around to the other side is pi as an angle. And therefore, this right angle is pi on 2. So 90 degrees is half of a pi. And then another half pi, and then another half pi, meaning to go around to here, where you would think is 270 degrees, is the same as 3 halves of pi. 3 pi on 2. And so today, at least initially, is about exploring this idea that the way we define an angle is pretty malleable. 360 we've done traditionally. You can make up your own system like the French tried to do, but the one that mathematicians use is the one related to distance around, and therefore the conversion is 180 degrees is 1 pi. Now, my screen is frozen. I'm going to bring that back up. Apologies. Oh. Cool. So, this gives us, I guess, a conversion. If we want to go from degrees to radians, we multiply by pi on 180. So if I give you 90, or let's say 45 degrees, if I want to convert that to radians, I multiply it by pi on 180. And then, well, that's 45 pi on 180. How many lots of 45 go into 180?
4.
Nice, 4. So it's pi on 4. And we're cancelling out a factor of 45 at the top and the bottom. 45 degrees is pi on 4. Which kind of makes sense, because if we say 90 degrees is pi on 2, a half pi, 45 degrees should be a half of a half pi, or a quarter pi. So, I'm going to stop talking, and basically I'd like you to do these, and question 6, where it says answer in decimals, clearly use your calculator, and you're allowed a calculator with the test. Otherwise, I wouldn't mind it if you didn't want to. It'll probably be useful to play with fractions a little to make sure you can simplify down. So, start of lesson, we'll only do this for 20 minutes or so, it's converting between radians and degrees.